Hello, this is Rick Powers from Western Technical College in Basic Statistics with Lesson 5, Describing Data, Part 1. After we collect our data, we need to describe it to understand the information from the data, whether in a table or in a graph or by calculating numbers. One of the most important and fundamental descriptions of data comes from a frequency distribution. This is a description of how many times, that is, how frequent certain responses were given. If we're putting responses into groups, then it's a grouped frequency distribution. Another important idea is to find the proportion of the data which is in each group. This is called the relative frequency and is often expressed as a percent. Relative frequency equals frequency of each group divided by the sum of all the frequencies. Note, recall a major purpose of statistics, what to expect. If the relative frequency for a category is less than 5%, then that may be evidence that that data category has unusual values for the data. Most of the time, if using numerical data, we look at the highest and the lowest values of the data for finding unusual events. Consider the following situation. We ask 50 different people, how many cars are in your household? Here's the data. Number of cars in the household, first column. Frequency, how many people said they had that number of cars. Then the relative frequency, the frequency of each group divided by the total, which was 50. And those are in proportions, or they could be expressed as percentages. One important idea, the measurement that we're actually interested in, is the number of cars. That's the data set. The frequency and relative frequency are used to organize and describe our data. Note that we would consider 5 cars to be unusually high, since it does not occur very often. We now begin to explore another important method of data description, graphing. Graphs will connect specific geometric ideas with information that we want to know about our data. Here's a summary of some geometric concepts for graphing. Bar graphs use rectangles, and we compare the sizes. Circle graphs use parts of circles. We compare the sizes as parts of a whole. Line graph uses lines, comparing the direction, up or down. Note that bar graphs and circle graphs are similar in the information we get from them, but circle graphs require that our data represents every part of a total. Example, the number of cars for Iowa, Wisconsin, and Michigan. I would use a bar graph since the numbers from those 3 states do not add to the total number of all cars. Another example, if I'm comparing the number of cars for different categories in Wisconsin, such as rural, urban, and suburban, then I could use a circle graph if those 3 categories add up to give me the total number of cars in Wisconsin. Big idea. Every graph must have a title, labels, and accuracy. When using a bar graph, it's important to have evenly sized horizontal widths since we want to have an accurate comparison. Also, on the vertical scale, it's important to have even spacing starting at 0 and going to the maximum value. This is needed for accurate comparison of the size of the rectangles. Note, for the line graph, we don't have to start with 0 on the vertical scale. In fact, sometimes we will zoom in on the graph in order to see clearly how the data changes with time. But always have clear and readable numbers on the vertical scale so that people can see the actual amounts of change. There is a sense of lying with statistics that happens when people use a graph to give an impression of change, but do not clearly state the numbers involved, which may not be changing by very much. So be aware that if a graph looks dramatic, it may not reflect the true state of affairs. Always check the actual numbers. We now want to consider making a graph that's based on a frequency distribution to be able to visualize how our data set is arranged. The graph that's based on a frequency distribution is called a histogram. Here's an example from what we had previously about cars per household. Note the title, note the labels on the horizontal and vertical, note the even spacing on the horizontal and the even spacing on the vertical scale. Note that a histogram is like a bar chart, except that the bars are connected to show that the data flows from one value to the next. Also, make sure to have 0 on the bottom, evenly spaced vertical scale, in order to accurately compare the frequencies. End of lesson 5.